So today we're going to start Chapter 7, Section 2. Today we're going to be verifying the trigonometric identities. Now, basically, the same thing that we did last night where it said to simplify, what's going to be different here is we're going to pick one side of our equation to simplify. You're going to look for the more complicated side of the equation, and that's the one you're going to simplify. And you're going to simplify it to the other side of the equal sign. Most of the questions in the homework tonight, the left side is more complicated, and that'll be the side that you're going to simplify. I think number 2 might be the only one that maybe the right side may be more complicated, but you're going to see what I'm talking about in a minute. Now, the little white box here, this is exactly the same information that was in the 7-1 notes. Again, we don't need the even odd identities, but it is in our book, or the cofunction. Again, all we're going to focus on are these reciprocal identities. And again, these are the quotient identities. And then also the Pythagorean identities. And again, be able to rearrange them just like I did in that example from last night's homework. Be able to solve them for any one of the terms in those equations. So our steps here, our tips for verifying, always look for the more complicated side, and that's the side you're going to simplify. Now, if you can factor it, that will be one technique. Another one, you may have to find a common denominator, like I did for the one that I just worked out. You may have to multiply, you may have to divide. A good tip is to try to get everything in terms of sines and cosines. So if you have reciprocals, change them to the reciprocal that involves either a sine or a cosine. And then also use Pythagorean identities when needed. You'll be doing substitution with those Pythagorean identities, and you may even have to multiply by a conjugate. So let's go ahead and let's try some examples. Now, I know it's sort of hard to see, but I guess you can see it clearly on your iPad. So what we're going to do here, just like yesterday, I'm going to simplify the more complicated side, and then the answer is the other side. So remember yesterday, this would have been the problem. And then this is the answer. So it's already telling you what you're simplifying it to. Now, you cannot treat this as an equation and like you're solving for x and using inverse operations. What we're doing is the same thing we did last night. We're just simplifying it. So for this first one, I'm going to actually start out by using a Pythagorean identity. So my left side is the more complicated. So what I'm going to do here is I'm going to be using the Pythagorean identity of tangent, I'll do it in black, tangent squared x plus 1 equals secant squared x. I'm going to subtract 1, and I'm going to get tangent squared x is equal to secant squared x minus 1. Notice right here, this is what I just simplified it to. So I'm going to substitute for secant squared x minus 1, and I'm going to put in there tangent squared x. So in here, I'm going to put tangent squared x over secant squared x. Now, next thing I'm going to do is use the tip that says change things to sines and cosines. So I'm going to change the secant into its reciprocal. And the reciprocal of secant is cosine. So I'm going to change secant squared x into 1 over cosine squared x. Now, what I'm going to do next is divide. So what I'm going to be doing here is the tangent squared x divided by the denominator. And then what I'm going to do here is a keep flip change. I'm also going to change my tangent squared x into its quotient identity. And the quotient identity for tangent is going to be sine squared x over cosine squared x. And then I'm doing a key flip change. So I'm going to flip this fraction upside down. And now I can simplify. My cosine squared x's cancel. And then I'm left with multiplying sine squared x times 1. And then 1 times 1 in the denominator. So this is what I get after I multiply. And then notice when you have a 1 in the denominator, it's just whatever the numerator is. And notice the other side of the equal sign, bring this down. You were trying to make it sine squared x. I got it there. So on the quiz and in the homework tonight, your answer to the questions is the work of the process of your simplification. I already told you the answer, it's sine squared x. So what's different from last night is you had to key into WebAssign sine squared x. Now tonight's homework is showing me the work. Yes?
So when we take the quiz?
So for this one, I'm trying to get this to equal 1. Again, my more complicated side is the left side. I'm going to immediately recognize that the numerator here is a Pythagorean identity. I know that sine squared x plus cosine squared x equals 1. And that's what I'm going to substitute for my numerator. So I'm going to change it to 1 over cosine squared x secant squared x. Next thing I'm going to do is change secant squared x to its reciprocal. And the reciprocal of secant is cosine. So I'm going to change this and make this 1 over cosine squared x. So I still have the 1 in the top. I still have the cosine squared x, but I'm going to change that secant into 1 over cosine squared x. Now notice in the denominator, the cosine squared x's cancel. And it becomes a 1. It doesn't disappear. So this becomes a 1 and a 1. And now I have 1 over 1, which simplifies to 1. And notice if I bring my 1 down, that's what I was trying to make it equal. Used a Pythagorean identity, then I used a reciprocal identity. Let's try the next one. Again, my left side is more complicated. I'm going to change that left side, and I'm going to change tangent x and secant x into sines and cosines. So for the tangent, I'm going to use the quotient identity because I know that tangent x is equal to sine x over cosine x. That's what I'm going to replace right here in the numerator. And then I know secant of x is equal to 1 over cosine. So these are the two I'm going to substitute. So the top is going to become sine x over cosine x. And then the denominator is going to become 1 over cosine x. Again, this black fraction bar means division. So I'm going to be dividing these two. So I'm going to be doing sine x over cosine x divided by 1 over cosine x. And again, you're going to do a keep flip change here. So keep the first fraction the same. And then flip the yellow one to its reciprocal. And then now notice that the cosine x's simplify to 1s. And then you're left with sine x over 1, which is really just sine x. And if you notice your right side, that's what it wanted you to get to. So it verified. So for the next one, again, my left side is more complicated because the right side's only a 1. So what I'm going to do here is I'm going to distribute. My first step is going to be multiplication on this one. Now, you could also use a Pythagorean identity. So let me show you that there's not always just one set way. So I'm actually going to do this 2 different ways. I'm going to first distribute, So you could also multiply here. So then if I use distributive property, sine squared x, when I times that by 1, and then here sine squared x times cotangent squared x. Now, what I need to do here is I'm going to change the cotangent into its reciprocal. Its quotient identity. So this one stays for now, and then this one stays, but I'm going to change this one into its quotient identity. So it's going to become cosine squared x over sine squared x. Notice the sine squared x's cancel, and now I'm left with sine squared x plus cosine squared x. And again, this is a Pythagorean identity. Remember that sine squared x plus cosine squared x equals 1. So I'm going to substitute a 1 here. And notice that's what we wanted to get to. This is one method, by multiplying and then using a quotient. Now I'm going to show you using a Pythagorean identity that there are different ways to do these. Now the other way you could have done this is, let me rewrite the problem here. Sine squared x times 1 plus cotangent squared x. I'm going to simplify this. I'm going to be using the Pythagorean identity that states that 1 plus cotangent squared x equals cosecant squared x. So I'm going to substitute this with this. So sine squared x replace with cosecant squared x. Then what I can do is turn this into its reciprocal, which is 1 over sine squared x. And I still had the black one here. And now I'll multiply. This simplifies diagonally. And this become a 1 and a 1. And then 1 times 1 is 1 over 1, which is 1. And that's where it wanted me to get to. So this is another way where you could have, instead of multiplying first, you could have done a substitution with the Pythagorean identity. Again, different ways to do these problems. The next one, number 5. I'm going to go ahead and simplify the left side. I'm going to use a Pythagorean identity. I'm going to use the sine squared x plus cosine squared x equals 1. I'm going to solve this for sine squared x. So I'm going to move the cosine to the other side. And sine squared x equals 1 minus cosine squared x. So what I'm going to do is I'm going to substitute sine squared x, and I'm going to put in its place 1 minus cosine squared x. So 1 minus cosine squared x. I still have the original cosine x on the bottom. Now, for this, what we're going to do here is break it apart. So this has already been subtracted or whatever with the common denominator. So what I'm going to do is I'm going to pull it apart and give each one of the numerator its own cosine x in the bottom. So I'm going to make it 1 over cosine x minus cosine squared x over cosine x. Because if you were to subtract this, then it would just go back to this. So I'm sort of undoing a subtraction problem. Now what I'm going to do is, again, glance over at what you're trying to get to. I'm trying to get to a secant. So I'm going to use my reciprocal identity because this is equivalent to secant. And this I can just simplify, get rid of the exponent here, and then this out of the bottom, and then I'm just left with cosine x. And that's where I wanted to get to. Now, let's say instead you were like, you know what? I think that right side's more complicated. You could also have simplified that one, because again, this one could go either way. So just to show you, I could have also simplified the right side to make it look like the left. So let's say instead I did that one on this one. So let's say instead I want to simplify the right side, and I want to make it look like this. So secant x minus cosine x. So what I'm going to do instead is I could turn secant x into its reciprocal, and then leave this alone for now. And now what I'm going to do is find a common denominator. My common denominator is going to be cosine x. So cosine x needs to get multiplied here and here. So then now I have 1 over cosine x minus cosine squared x over cosine x. And then I get, in the numerator, it's now 1 minus cosine squared x over cosine x. And then I can use my Pythagorean identity here and make this sine squared x over cosine x. And now I made it look like the left side. So this one could have gone either way. You just choose one and then you make it look like the other side. Again, always pick the more complicated side. So this one, either one would have been fine to pick. Then number 6, I'm going to simplify the fraction. That's going to be my more complicated side. And what I'm going to do here to simplify this one, I'm going to be using the conjugate. So I'm going to go ahead and take my 1 over secant. That's kind of hard to see in the purple. Let's do yellow maybe. So 1 over secant x minus tangent x. So what I'm going to do is multiply this by its conjugate. And the conjugate is going to be secant x plus tangent x. And then again, same thing, tangent x. So what I need to do here, the top when I multiply it, it's just times 1. So the numerator is just going to be secant x plus tangent x. But the bottom, I got to FOIL it. But remember, just like before when we did this with the imaginary numbers and with the radicals, really all we need to do is first and last. Because when I FOIL this, outer and inner are going to cancel. So I'm just going to do first and last. And when I do that, I end up getting secant squared x minus tangent squared x. You could do the whole FOIL thing and you'll see outer and inner are going to cancel. Now, if you notice, this denominator, the blue, we've got, did I do it on this slide? No, I didn't. So let me just do it again. So I'm going to be using the Pythagorean identity, tangent squared x plus 1 equals secant squared x. I'm going to go ahead and rearrange this by moving secant over. And then I get tangent squared x minus secant squared x plus 1 equals 0. And again, I want it to look like the blue. So I'm just going to move the 1 over. And now I have tangent squared x minus secant squared x equals -1. This is what I'm going to substitute for the blue. So now I have the green, secant x plus tangent x, and then it's divided by or over -1. Or +1. What did I do here? that. I did it the wrong way. Let me rearrange this again. So I needed to move tangent to the other side because it was secant minus tangent. So I needed to move tangent over. So tangent squared x, subtract it. And then I get 1 equals secant squared x minus tangent squared x. And now I'm substituting a positive 1 because that's what this equals. So then anything divided by 1 is just itself. So secant x plus tangent x, that's what I was trying to get. So it equals the same thing. It checks. All right, next one. Whenever I see something being added, I'm going to look for a common denominator. So what I'm going to do here is I'm going to simplify the right side on this one. And my common denominator is going to be both of these. So I'm going to go ahead and I can look and see that the first one is missing the 1 plus sine x. So that's what I'm going to multiply to the top and the bottom. And then this side is missing the 1 minus sine x. So now let me go ahead and multiply this. So the red becomes 1 plus sine x over 1 plus sine x times 1 minus sine x plus, and now the blue, 1 minus sine x over 1 plus sine x times 1 minus sine x. Now that I have a common denominator, I can add my numerators. Now my only like terms here are going to be the 1 and the 1. So 1 plus 1, and that's going to give me 2. But notice the sign, positive sine x minus sine x, these cancel. So now I have 2 over, and I'm going to multiply the bottom. So no, well, let me just go ahead and fill it in. 1 plus, it's got the common denominator now. Now what I'm going to do is FOIL the bottom. So once I multiply the bottom, this is like the difference of 2 squares. So if I FOIL it, outer and inner are going to cancel. So then this is just going to become 1 minus sine squared x after I FOIL it. Again, I'm going to use my Pythagorean identity, my sine squared x plus cosine squared x equals 1. I'm going to go ahead and move the sine over, sine squared x over. And now I have cosine squared x equals 1 minus sine squared x. So this is what I'm going to substitute. Cosine squared x for this denominator. So now I have 2 over cosine squared x. And again, let's take a peek at what we want to get to. We need to get secant here. So remember that cosine squared x is equal to 1 over secant squared x. So this is what I'm going to substitute in the bottom. So this is going to go here. So now I have 2 over 1 over secant squared x. And again, this black fraction bar means division. So really what we're doing is 2 divided by 1 over secant squared x. And again, you're going to get to the habit where you don't need to show this division. You're just going to know you're going to flip that bottom upside down and put it up at the top. So this really becomes 2 over 1 times secant squared x over 1. And then when I multiply it, 2 times secant squared x. And if you notice, that's what the left side had. So it verified. So the next one is the same. We're going to be finding a common denominator, but this time we have cosine in it. So again, my common denominator is going to be both. So this one needs the 1 plus. Does that show up? No. This one needs the 1 plus cosine x. And the same thing to the denominator. This one needs the 1 minus cosine x. So once I multiply it by 1, I now get, let's see if green shows up better. Good. So 1 plus cosine x over both of them, 1 plus cosine x times 1 minus cosine x. And then here's the 1 minus cosine x over the same thing, 1 plus cosine x, 1 minus cosine x. Now I need to combine my like terms. So in the numerator, the cosines cancel, but then again, I get the 1 plus 1, and I get 2. So now I have 2 in the top, and then I have the same denominator now. I'm going to FOIL the bottom, just like I did before. Again, my outer and inner are going to cancel, so I'm just really doing first and last. So this becomes 1 minus cosine squared x. And again, I need it to be cosecant. So I'm going to use my same Pythagorean identity. I'm going to replace this with sine squared. So it'll become 2 over sine squared x. And then remember that the reciprocal for sine is cosecant. So then it'll end up being, let me just go this way, 2 over 1 divided by cosecant squared x, and then flip it. And then it becomes 2 cosecant squared x. And that's what we had on the left side, so it verified. Let's try number 9. For this one, I'm going to go ahead and use 2 Pythagorean identities, and I'm going to do substitution. So I'm going to be using the tan squared x plus 1 equals secant squared x. And then I'm also going to be using the sine squared x plus cosine squared x equals 1, because what I'm going to do here is rearrange it. And when I do that, if I move this over, sine squared x plus cosine squared x minus 1 equals 0, and then move the sign over here, and it becomes negative. And that's what I'm substituting here. So the first one, I'm replacing this with secant squared x. And then I'm replacing this one with negative sine squared x. Next, what I'm going to do is turn the blue one into its reciprocal. Let me switch maybe to yellow. Does that show up better? Or even black? All right, so I'm going to change this to its reciprocal, which is 1 over cosine squared x. And then the green, I'm just going to leave it here. And now I'm going to multiply it. So I get negative sine squared x over cosine squared x. And then I'm going to use my quotient identity. And this is equal to negative tan squared x, which is what it wanted me to make it equal. Number 10, I'm going to do the same thing. I'm going to use 2 Pythagorean identities. Let's try 10. So again, I'm going to use the 2 Pythagorean identities. So again, for the first one, I'm going to be using the tan squared x plus 1 equals secant squared x. I'm going to move the 1 over. So tan squared x is equal to secant squared x minus 1. So in here, I'm going to put tan squared x. And then I'm going to do, again, same one, sine squared x plus cosine squared x equals 1. I need to get this in the right order. So sine squared x minus 1 plus cosine x squared x equals 0. Then move cosine to the other side. So now I have sine squared x minus 1 equals negative cosine squared x. And that's what I'm going to substitute right here. So then this becomes negative cosine squared x. Now what I'm going to do is change it to sines and cosines. So I'm going to change tangent to its quotient. So it becomes sine squared x over cosine squared x. And then, let me change the color here. Then this stays the same. Let me just do it in green. I think it shows up better. And now I can simplify diagonally. So then this becomes a 1 and a negative 1. And then I can multiply it. And then the final answer is negative sine squared x, which is what was on the right. So I got it to verify. Everything's going to verify. You will be able to simplify everything. And then let's do one last one. I'm going to change everything to sines and cosines. So for number 11, I'm going to change tangent to its quotient and cosecant to its reciprocal. So tangent becomes sine x over cosine x, and then cosecant is going to become 1 over sine x. These are being multiplied. I can simplify diagonally, make them 1s, and then I'm left with 1 over cosine x, and the reciprocal to cosine is secant. So this simplifies to secant x, which is what it wanted me to get to. So we'll stop here, and then I'll do the last 6 examples tomorrow. You have enough knowledge to do your 7 problems for homework. Again, it's a PDF. The answers to the homework is all of the work that it takes you to simplify it to the other side of the equation.